All right, let me record the class. So morning. This is our week 2 for CSE 8A. Okay. Announcements. Number 1, our PA2 was released yesterday. Okay. And as well as our lab tomorrow, right? So we know you have the lab activity, you also have the lab quiz. Make sure that you finish the lab activity by Wednesday night, okay? And then PA2 is still this Sunday night, right? This coming Sunday night. We also have a quiz from last week. Let me see. I would release the quiz. In fact, I think we can release that quiz now. The average of quiz 1 is, let me see. The average of quiz 1 is about 71%. Okay, 71%. So let me release it. Sorry. I think I already released quiz 1. You can see it on Griscope. Okay. If you have questions about the quiz, then let me know. I think there was someone asking about quiz. There was a PA2 location. Okay. All right, so I think it's fixed. I didn't see any questions about quiz 1. So this Friday we're gonna have another quiz, which is quiz 2, and Wednesday we have the lab. Okay. Are there any questions about the logistics? So summer class moves very, very fast. Okay, you cannot slack off. If you slack off, you're gonna be behind. All right, so the plan for today is we'll talk about how to get started with a coding project, and also talk about the range for looping structures. There is one question: Can you go over the blank scenarios for quiz 1? What do you mean blank scenarios? You mean one of the questions there? Let's see. I can find out the conditionals. Okay. So for quiz 1, if you look at it, conditionals. Okay. Let's check this one. Okay. I don't know if there's a way that I can export it. Let me see. Is there a way I can export the quiz? Download? No, I can't. So let's look at this conditional. Okay. So given this code segment, please provide the answers to these 3 blanks. So the code prints out the expected result. Your answers to these blanks are either true or false. If it's impossible for you to generate the output, then you just say, just select none for all the 3 blanks. Okay. So this is the code, and I want to output 5 and 10. So if you look at print out 5 would be here, print out 10 here, print out 50 would be there. And this is print out 15, right? If X is 5, Y is 10. Now I want to print out 5 and 10. In other words, I have these 2, right? 5 and 10. So it's impossible because this is if, else if. So it's impossible for you to print out both. That's why the answer is none, none, none. Okay. Next one, I print out 10 and 15. 10 would be here. 15 would be here. So in order for me to print out this 10, I must make sure blank 1 is false. For blank 2, it must be true. For this one, in order for me to print out 15, this blank 3 must be false. So it should be false, true, false. That's why the answer is here. Okay. And then 1050. 1050 means you print out this part and you print out this part. So the first part must be false in order for you to get into this else if. And this part would be true, false, true, true, false, true, true. So that's why this is the right answer. Okay. Last one, print out 10, 10, 5. 10, 10, 5. This is 10. I cannot print out another 10, can I? So it's none, none, none. That's why the answer is none, none, none here. Hopefully that makes sense. Any other questions about quiz 1? Okay. For this Friday, we'll have another quiz, which is similar like this one. Okay. Basically, this Friday's quiz is gonna test other parts that we learned this week, today as well as Thursday. Okay. All right. Anything else before we get started with the materials today? Okay. So week 2 Tuesday, we'll see how far we can go today. The first thing I want to talk about is how to get started. Okay. PA2 was released. Let me kind of show you PA2 in here. Let's see. Here, where is PA2? Let me grab it out. Add stem PA2. Okay. So if you look at PA2, make sure. Okay. There are 3 functions that you have to write, right? So if you look at the write up, it asks you to create these 3 files, and each of the files have a single function that you have to write. And you can use all these functions that we ask you to write, and then you finish every problem in here, okay? And then there will be a small conceptual question component in here that you work on, okay? Now, when you are asked to write functions, it is important that you know how to get started, okay? So the first thing we'll do is we'll say, okay, if I'm asked to write a function, for example, for dining hall menus, how am I even get started? Okay. For beginners, I sometimes see people struggle with this, and this is from years of experience. Okay, so I've been teaching for a long time. The kind of the question students ask me will be, well, how do I even get started? I have no idea how to get started. I understand everything you talk about in class, but when I'm given this problem, I have no idea how to get started. And that's why I designed these strategies to help us. Okay. There's one question, will there be, can we have more time to take the quiz? Right now it's like 20 minutes, right? I can try to give you some extra time. I don't think that's gonna be a big problem. I'll try to give you maybe 30 minutes before I forget. I can do that. Okay, hold on. Let me set up Gradescope in here. I can give you some extra time. Hold on. Otherwise, I will forget. So 30 minutes. Okay, I can give you some extra time. And then 30 minutes. Okay. Will there be midterm study guides? Oh, let me see. I may be able to find what I had before I modified, but Basically, the midterm would cover everything we learned in the first 3 weeks. And when you try to prepare for the midterm, the most important thing that you should prepare are the slides and the lectures, right? You don't want to reread the book. The book is for you to get an idea of how to, like what we'll talk about in class. But slides, the notes, the PAs, the quizzes we have had, those are the problem. Those are the things you should prepare. Don't reread the book. Okay, I'll try to come up with a midterm review guide. Okay. Any other questions? Okay. So let me come here. So we'll get started in here. Now, step number 1, how to get started with coding. It deals with coding habits. Okay. So for this class, it might be the first class that you take about CS or coding. For some of you, maybe this will be the only class you take. Okay. But you never know. You never know what you'll be doing when you graduate. Real story, just last quarter, in the spring quarter, my tutors and I went to this local robotic company called Brain Corp. They make those robots that can help supermarkets to reshelf. And we were meeting with their engineers, and one of the engineers was a student from UCSD. And she said, "Oh, I took your class." And that was the only class I took. She took CSE 11. That's the only coding class she took in college. And now she's in the computing field. She writes code almost on a daily basis. Okay. So you never know what may come in handy when you graduate. Okay. So it's important that you have a good sense of how to get started. And good habits are very, very important because it will help you with this class as well as future classes. You say, well, I already have a ton of coding experience before I take this CSE 8A. It doesn't mean that you have good habits. In fact, some of the most clever, some of the most experienced people may have a bad habit. Okay. So how do you know you have good habits? It is measured against how much time you design on paper. In other words, you're trying to come up with an idea. How long does it take you? And are your ideas correct? How did you come up with that idea? How did you verify if your idea is right or wrong? Those are part of the time that should take a majority of the time as you work on the PA, for example. You shouldn't spend too much time debugging. Debugging is a very frustrating process. It's bad, right? You'll get angry, you'll get upset. You say, my code just doesn't work. What's wrong with it? Most likely it is because you have the wrong idea. Okay. That's what happens. Just for example, you say, I want to go from San Diego to LA. If you keep driving south, you'll never get to LA. And you may be frustrated. How come I'm not LA at this time? It's because you started at the wrong foot. Your idea is wrong. That's as easy as that. Okay. So what I want to convey in this part of the lecture is, how do I design my idea? How do I know if my idea is right or wrong? And then the coding part, in fact, is the easy part. Very soon, as you get more and more comfortable with the syntax, coding part shouldn't be too bad. The idea part will be the most challenging component. Okay. So let's use a case study in here. Okay, let's use a case study. So you are asked to do this, to write this function for one of the PAs, for example. Say sum2 num list. This is a function called sum2. You are given a list. Given the list of integers, you want to return the sum of the first two things in this list. If the length is less than 2, you just sum up the elements that exist. If the list length is 0, you return none type. Okay, so this is the write-up, right? So you're given this thing, you're supposed to write this. You're given some description. Most likely in the write-up, you're also given some sort of examples, okay? So for example, I say, okay, if the list is 1, 3, 5, 7, you're supposed to return 4. You add up the first two things. That's it, right? Now the question is, how do I do it? How do I do it? If you're experienced, probably something naturally would, like, the idea would just come to your mind right away. But if I'm a beginner, I have no idea where to get started. Step number 1, when you are trying to get started with the problem, is understand what you are supposed to do. Okay, you want to read the write-up a few times. You can print it out, you can highlight it, do whatever you need to do to make sure that you fully understand what you are supposed to do. If you read the write-up and say, I still have no idea what am I supposed to do, go to the discussion help problem sections, right? On Wednesdays, we have help sections. You can go there and ask for help. You can also show up during tutor hours. You can also show up during office hours, and we'll help you to understand it and explain, clarify. Okay? So that's step number 1. For this one, probably it's straightforward enough for us to understand it. Now, you say, okay, I understand the problem now. How do you know you understand it? This is kind of a philosophical. How do you know you understand it? The only way you can know for sure that you understand the problem is you can solve the problem. How do I know I can solve the problem? You can come up with test cases for yourself. Okay. So for example, if I say 1, 3, 5, 7, I'm expecting a 4. Right? Your mind is okay. I add up the two things. I'm expecting a 4. If you can come up with these tests, it means you understand the problem. If you have no idea how I should design these tests, it means you don't understand what you are supposed to do. Okay. And when you design these tests, in general, I'd say around 10 of them. You should come up with around 10 tests. Some of the tests are the easy tests, like I have 2, 7, 10. I'm expecting a 9. These are the normal cases. And your problem should be able to handle normal cases. If I give you a nice list, like 91, 1, 5, and 5, I'm expecting a 0. So these are normal cases. You can also think about cases that are kind of special, that are tricky. We call them the edge cases. For example, edge cases, like if I give you a 1, 3, I'm expecting a 4. I have exactly two things. I'm returning the sum of them. How about I only have one thing? What am I supposed to do? If I have no idea, go back, read it up. It looks like I should just add up this thing. I should get a 3. What if I have empty? If it's empty, I should return none. So I have about 6 of them now. How about I have a negative value? Would this work? Would it return negative 3? Right? If I have a like a let me see. Normal cases, maybe I can have some duplicates, right? Would duplicates matter? Most likely it won't, but I'll test it out. This one should give me 100, right? So that's it. These test cases should be written on paper. You grab the piece of paper, you write it down. Don't lose this piece of paper. Okay, it's important. Now, once I have these test cases, in fact, as you try to come up with these test cases, you are in your mind solving the problem. You say, okay, if this is the input, that's the output I'm expecting. So you are already solving the problem. Now you just need to formulate how you solve it as a human being into a piece of code that the machines can execute. You should know that the way machines solve a certain problem is different from how humans solve it. But for easy problems that we are dealing with in CSE 8A, in general, the ideas are similar. Okay. So once you come up with the idea, once you come up with the test case, you are going to formulate your idea. Okay. So how do I do it? Again, this is design on paper. So step number 1, I probably want to find out the length of the list. I want to figure this out, right? And you can draw it, you can draw a flow chart, you can write it out, whatever that makes sense to you. So, okay. This thing, maybe I should write it out. Okay, if the length is 0, I will give back none. If the length is bigger than 2, I will add the first 2 elements. If the length is 1, I would just add the first element. And that's it. That's my idea. It's possible that your idea is wrong to start with, right? Now, how do I know if my idea is wrong? The way you test your idea is you first remember you have these tests that you created beforehand. Now you are using them. So if I pass in 1, 3, 5, 7, I say, what's the length of the list? It's 4. And I look at the length, and this part is false. This part is good. So it's longer than 2. I'll add the first 2 elements. I get 4. So this one checks out. And then you test against every test case. And for example, if I have 1, 3, the length is 2, right? The length of my list is 2. Is length 0? No. Is length bigger than 2? It's not. I probably should say its length is bigger than or equal to 2. If the length is bigger than or equal to 2, I should just add up the first 2 things. This one will give me a 4. Now it works. One thing I want to remind everyone is, as you try to kind of perfect your idea, it's possible that you change your idea. Once you change your idea, you need to retest against all the other test cases that used to pass. Because it's possible that you say, I have this idea, it passed 10 test cases, but failed 2. And you look at those 2 test cases and say, oh, I forgot to do this thing. It's important that once you update your idea, you go back and retest those 10 test cases. Otherwise, it's possible that you now pass those 2 test cases, but they're failing some of the other test cases that you used to be able to take care of. So once you update this, you say, okay, how about this one? 1, 3, 5, 7. Is this still good? It is still good. 1, 3 now is also good. How about empty bracket? The length would be 0. So if length is 0, I return none. Looks good. So you have to make sure that your idea on paper, at least, would pass all these tests that you came up with. As you can see, the more tests you come up with, the more chance that your code would be good. Okay. Any questions? All right. So let's look at step number 3. Step number 1 is test case. Step number 2 is design on paper. And this part is to test on paper. We already did it. Okay. Step number 4 is you start to write the code. When you are translating your idea into the piece of code, You want to make sure, number one, don't make syntax mistakes. In the beginning, you will make kind of small syntax errors, okay? But you should also know that once you finish coding, you want to test your code thoroughly, at least using the same test cases you have on paper. Let me show you how you can do it, okay? So let me start in here. All right, so how do I write the code for toSum? This is the function. So I'm gonna do something. Right now, let's think about this, right? I would, for example, okay, the first thing what you want to do is you say, I don't even have this function. I have no idea. In fact, you can start writing the code even if you have no idea, if you know the test cases. Right now, I say this one always return 0, for example. This is called a stub. You just have this function. It doesn't really do anything correct. You just say, okay, this is a placeholder. And because of this, you can start to call this function. So you say print, pass in 1, 3, 5, 7. I expect a 4. And what do I got? I'll call sum2 by passing in 1, 3, 5, 7. We'll see what we got. Okay. And then you basically type in all the test cases that you already have. So I'll pass in 1, 3. I would expect the 4. And what do I got? Sum2, 1, 3. And you print again. I'll pass in a empty list. I expect none. What do I got? I call this function by passing an empty list. And this is the last thing I will type in. And you only need to type in this once. You don't have to type in many, many times. So last thing is pass in, I would say, -3. I expect -3. What do I got? Sum2, -3. If I run this code, you're gonna see it doesn't work, right? Python sum2. You see, I pass in this, I expect 4, I got a 0. I'm expecting quite a few things, but I always get 0 because this code always returns 0. But as I try to fix this code, I try to complete the code, hopefully most of these tests will be right. Right? In fact, in the end, all of them should be right. Now let's write this code. Right? First thing I want to say, okay, I want to know the length. I say L length equals to len of num list. Okay, I figure out the length. Now I say if length is the same as 0, for example, okay, I am gonna intentionally make some mistakes in here. Okay, so I say okay, if the length is 0, I need to give a none. So I would say print none. Okay, and then if the length is bigger than or equal to 2, I would print the sum of the first 2 elements. Num list, I know it's 1 plus num list 2. If the length is the same as 1, I'll print num list 1. Right? I'm done. If this is my interpretation of my algorithm, right? So it may be right, it may be wrong. How do I know it? You run your code. Oh, it crashed. In other words, something is wrong. Something is wrong. How do I know where things go wrong? The first part, pass in 1, 3, 5, 7, expect 4, I got a none. and then I got the index out of range. The first thing, I shouldn't get a none. Why do I get a none? Because you're supposed to return none. You have a print none. So how do I know this? You think about this. The function is supposed to return something. So you should return the statement. So you say, well, what if I can't figure this out? You come to office hours, you come to tutor hours, will help you to say, oh, maybe you should think about return vs print, right? So I say, oh, return none. Most likely, I'm gonna have to return these things instead of that. So return num1. All right. So hopefully this would solve more problems. Run the code again. I still have an error, but hopefully it's better now. Pass in 1, 3, 5, 7. I'm expecting 4, but I got 8. Interesting. How did I get 8? Right? Is it 1 plus 7? Is that what we did? Or is it 3 plus 5? Or something is going on. I have no idea. I look at my code. I have no idea where it went wrong. You can try to guess. If I'm running this part, the length is 4, right? Did I have the right length? That's when you start to try to debug. This is the debugging process. Okay? Okay. How do I know which part of my code is wrong? Your code is going, right? Your code is running. And you need to figure out what's wrong in here. For our code, there are 2 ways you can debug your code. First thing is you add in print statement. I say, let me print out length. So I say printing length to check, and then I print out length and see if I get the right length. Let's check this one. If I run it, printing length to track is 4. So it looks good. The length is 4. So this part is not wrong. Now I'm returning these things. Most likely I'm wrong in here, right? Because if I return this number 1, it's going to give me a 3. Does it give me a 1? No, you may realize, oh, I used the wrong index. Index start from 0. Maybe this is what we have. No, maybe my code is correct. If you run it again, it looks like now everything is perfect. Okay. So expect 4 get 4, expect 4 get 4, expect none get none, except -3 to a -3. Okay. Are there any questions about this? So you write your code, you test it, and then when you say my code works 100% now, you are ready to mark. I think one of our tutors, she put in all these marks so you can test your code by yourself. Isn't our tutors great? Any questions about this? About this? So this is how you get started. It seems to make more sense. Okay, hopefully. So getting started is the trickiest part for beginners. Okay, and in fact, when I was talking to new faculty who just get started to teach, they have no idea that this is the first hurdle. And pretty much every instructor are using these slides to help our student getting started, because you don't realize how beginners struggle, because we are not beginners anymore. We forgot how we struggled before. Hopefully this is useful. Okay, hopefully this is useful. Now I want to talk a little bit about these strings. So for this PA, you may have to process strings, and I had a recording. Okay, so instead of going through this during the lecture, what I would recommend is I posted this recording, commonly used string function recording. So if you click here, you should be able to see the recording in here. And it kind of tells you how to test and also what each of those functions do. I recorded this, I think, in winter. But the idea is feel free to watch this recording, 13-minute long recording that talks about these functions. Okay. You may find this useful for the PA. Just briefly, index for string would tell you where something is, right? Strip would remove leading and trailing spaces. So what do you mean? You can say space, space, CSE 8A, space, S23, space, space. If you say this thing dot strip, what this strip function will do is it's going to get rid of these two. The space in the middle of the string is not being affected. Just be careful on that. Okay. So it is useful when you try to read in raw data. Now, for split, what this split function does is to break the string into a list of strings based on a separator. And today, I think we already talked about lists before. So you basically can think about, you end up with a list of strings, and then you say split this string based on spaces. That's going to be useful. You also have lower and upper. They basically convert a string into all lowercase or uppercase. You can look at the prototypes of all these functions in here. And it's better you know these functions to help you. So instead of reinventing the wheel, you are allowed to use these functions. Okay. Any questions for this one? All right, next thing. So a big part of today's class will be devoted to loops. Okay. So loops are structures that would allow us to repeat. Okay. So you can think about loops allow us to repeat. That's one way to think about loops. What do you mean you need to repeat? For example, we have 40-some students in our CSE 8A in this summer session 1. And so let me assign everyone with a letter grade. Now, what is that letter grade that I have? It depends on your overall grade. So what I will do is I will say, let me grab a student's overall grade, then I will give a letter grade. Grab another student's overall grade, give a letter grade. So I need to repeat this 43 times, 44 times. And that's the idea of repeating. If you know how many times your loop is going to repeat, in general, we use for loops. Okay. If you say, I want to repeat something, but I have no idea how many times I will repeat. It's not even known. Like, for example, if I say for a class, how many times do I have to repeat when I try to assign letter grade? It depends on how many students you have. If you have 20 students, you repeat 20 times. You have 200 students, you repeat 200 times. So the idea is you need to start to think about how many times, right? And you know that maybe it's in a variable, maybe it's just a constant, but you know that. while loop is another looping structure. You say, I have no idea how many times I have to loop. For example, if you say Google asks you to change your password, you say, hey, your password is weak, you need to change it. And if I'm writing that password changing program for Google, you got to think, how many times would it take the user to give me a strong password? Maybe once, maybe twice, maybe 5 times, maybe 20 times, maybe never. The user would never come up with a strong password. So you have no idea before the user, you have no idea how many times the user would have to try before the password is considered to be strong, right? The password must have a letter, a digit, uppercase, lowercase, must have some weird symbols. So must be of certain length. So in those situations, since you have no idea how many times the user would take, you may use a while loop. Okay, so both looping structures are useful, although in this class, we use for loops more often than while loops. Okay, so we'll get started with for loops, and then we'll talk about while loops. Okay, so let's look at for loop. So what does for loop do? For loop in this class, in general, we're trying to process a list or process a string, okay? And this is the first version of the for loop for an element in this thing. This thing can be a list. If this is a list, then ELEM would take the value of each of the element in the list. This thing can also be a string. If that's the case, ELEM would be individual characters in the string. That's what this for loop does. So for this element in this container, colon, and then you have the statements you want to repeat. Okay. So let's look at one example here. For E in this list, I print E. So how does Python evaluate this statement? The first value, so in this for loop, this is a for each loop. We call this for each loop the first version. So E would be taking a value from this list. Initially, in the first round, E would take a value of 8. And then you say print E, 8 will be printed. In the next round, E would take the second value of the list, E would be 11. Then you say print E, just print out 11. As you can imagine, as you go through different rounds, E would take different values. These are the classes that in general you would take after you finish 8A. So you're gonna print out all these values. Are there any questions about this? All right. Now, this is when you print out the value in here. Let's look at some examples. For X in this list, and I'm doing this, what will be printed out? Let's vote in, please. So X would take the value of each of these elements in the list. You can vote in whenever you're ready. All right, vote in, please. All right, so let's take a look at this. A lot of us voted for D, but some of us also voted for other choices. Let's see. So X would take each of the values in here, right? So X would be 4, 6, 8, 9, and 10. And every time the loop runs, we're checking this thing. What we're basically saying, if it's even and X is bigger than 6. So when X is 4, it's even but not bigger than 6. I don't print. 6 is even, but it's not bigger than 6. So the first value that will be printed out is 8. And then the next thing is 9. 9 is not even. So 9 is not printed out. 10 is printed out. So D is the correct answer. Here. Questions? So D in here is the right answer. Okay. Percentage sign means it's a remainder, right? It's remainder. Next thing. There is a question. Hold on. What does percentage 2? Let me bring up add stem. Do a quick demo in here. Right. So just start up in here. Python. All right. So what does percentage do? Percentage means remainder. Okay. Percentage 2 means this number divided by 2. What is the remainder? What is the remainder? And so why do I care about the remainder? In math, you say, okay, how do I tell if a number is even or odd? You say, oh, if it ends with 2, 4, 6, 8, 0, then it's even. Otherwise, it's odd. That's the mathematical way you determine that. For coding, we don't want to check the last digit because checking the last digit would be too slow. What we do is you use remainder. So if you divide this number by 2 and you end up with 0 as a remainder, then this number can be divided by 2 completely. So it is an even number. So for example, you say 8 mod 2, that's 0. 12 mod 2, that's 0. A big number, mod 2, that's, that's 0. Mod 2, that's 0. But if you have an even number, that's a 1. So this is the remainder. And we use this mod 2 and compare the result with 0 to check if this number is even or odd. You can also say, how about 56 mod 6? If you use 56 divided by 6, what's the remainder? I don't know what the value is. It's 2. So 56 is not a multiple of 6. Right? But you can say 56 is a multiple of 7 because the remainder is 0. That's how we determine even odd or if a number is a multiple of another number. Okay. So any other question? All right. So that's this modulus. Now, how about this function? Of this function, and I'm given a list. This num is a list. What does this function do? Which one of the choices looks good? You can vote in whenever you're ready. Okay. Oh, we totally disagree with each other on this one. All right, we'll stop the vote now. If you look at it, the votes are all over the place. Now what does this one do? We have a c equals to 0. For n in nums, you increase c by 1. You increase c by 1. So if you look at this code, C0, I'm going through this list, n would take every element in this list. And every time the loop runs, I'm increasing c by 1. If this list has, for example, I'm saying 1, 3, 5. Initially, n is 1, and then c would become 1, and then n becomes 3, c becomes 2, and then n becomes 5, c becomes 3. So c would return 3. In other words, c would be the length of the list, or the number of values in the list. So the correct answer is B. The correct answer is B. It doesn't always return 0. It doesn't always return 0. Okay. So the better name is probably just call this the length. And this C is more like a size variable or length, right? Any questions about this one? So I'm not saying n equals to n plus 1. I'm saying c equals to c plus 1. Okay. All right, so this is the exercise in here. I think it's time for us to take a quick break. Okay, well, it's slightly 2 minutes in our break time. So let's do this. Come back 12:02. We'll continue our discussion about loops. Okay, so break time, guys. All right, folks, get ready to come back in 1 minute. So we'll get started at 12:03. For those of you who are back, look at this exercise. I have this courses, and then for E in the courses, I say E equals to E plus 1. Then I print out this course. What would you say will be printed out in here? Okay, so you can vote in whenever you're ready. All right, vote in. Okay. Okay, so a lot of us said A, right? So about 80% of us said A, 20% said B. Unfortunately, the correct answer is B. A majority of us got this one wrong. Okay, so why? How come this code doesn't increase each of these values by 1, right? Why does the list stay the same? The idea goes like this. For this for loop, right? Initially, we know that E, the first value E would take is 8, right? So it's 8, and then we say E equals E plus 1. E is changing to 9, but it's this value of the list is not changed. E is changed, not the data in the list. Okay, so similarly for 11. Then what does this for loop do? For loop, the variable, this E, is given a certain value of the list. The cost is 0. In the first round, E equals to cost is 0. Whatever cost is 0 is, you get 8, so E would have a value of 8 in there. That's what you have. Okay, so you may change this E into 9 into anything, but the original data is not changed. In other words, this for loop, you cannot use this for loop to change the list. So when you print out courses, it's still the same. That's why. Okay. Questions about this? And some of you may ask, what if I want to change the list? Right? How should I do it? That's the next thing we'll discuss. That's the next thing. Okay. So when you use this kind of for loop, you cannot change the list. You can't change the list. Now, let's look at how do I change a list? You have to use another version of the for loop. That's what you need. Okay. So in order for you to use the other version of the for loop, you must understand this important struct in Python is called range. So this is a function that would generate arithmetic sequence. Arithmetic sequence are the numbers where the difference between the next term and the previous term are always the same. Like for example, 1, 3, 5, 7, 9, and go on. This is arithmetic sequence. Or 0, 1, 2, 3, 4. This is the arithmetic sequence. What this range really does is it can give us the arithmetic sequence, So it's similar to slicing. Very, very similar to slicing. So you are given three things, A, B, and step. A can be omitted. A is the beginning. B is the ending point. Step is like how much it changes. If A is omitted, by default, you assume the beginning is 0. If you omit the step size, it is assumed to be 1. So this is kind of what this range does. It's going to give you this sequence of numbers. And then why do I need this sequence of numbers? You can use this sequence of numbers to serve as the index into a list or into a string. And you can use the indexing approach to change the list or change the string. Okay, so that's kind of the purpose of having this range. This is the mathematical formula of how to generate the arithmetic sequence. But the idea is you start from A, and then when I is 0, you end up with A. And then I is 1, you end up A with A plus step. When I is 2 is A plus 2 step. You go all the way to B, but not including B. Okay. So you make sure you are either less than B or bigger than B, depending on what the sign of the step variable is. Okay. So if you understand slicing, the range is basically the same, except you use commas to separate those three arguments. Okay. Let's look at some examples in here. Range 1, 5. What is the sequence that is generated by this function called range? Vote in. Okay. One, 5. Basically, if you only have two things, this is where it starts. This is where it ends. Right? But not including the ending point. All right. Let's see. Most of us voted for A. 1, 2, 3, 4, and that is the correct answer, right? To start from 1, and there is no step size. So we assume the step size is 0. So next thing will be 2, 3, 4, and then 5, not including the ending point. So it should be 1, 2, 3, 4. Okay, should be 1, 2, 3, 4. Not 1, 2, 3, 4, 5. The ending point is not included. This is true for slicing for list, slicing for strings, also good for range. 99% of ranges in coding doesn't include the right side. It includes the left side. Okay. How about 152? What will be generated by this range? Let's vote in. 1, 5, 2. So this is the starting point, ending point, and this is the step size, right? Vote in. Okay. All right. let's see, I think we have a pretty good consensus on this one. The way you generate the sequences start from 1, and then the step size is 2. So 1 plus 2 is 3. 3 plus 2 is 5, but not including 5. So C is the right answer. C is the right answer. Okay. Are there any questions? All right. Next one. Which one of them would produce this list? So how do I convert a range to a list? You just use list parenthesis. This would convert this sequence of range into a list. Which one of them, or which ones of them, would give me 1, 2, 3, 4, 5? This one is slightly more complicated, so take your time. Think about this. All right. So the most popular choice is B, 3 only. Let's check, right? So what kind of sequence would number 1 give us? You're looking at starting from 0, 1, 2, 3, 4, because it doesn't include 5. So A or C are wrong, right? It is not 1, 2, 3, 4, 5. Now, how about range 5? If you only have one number, you're omitting the beginning, you're omitting the step size. If you omit the beginning, start from 0. 0, 1, 2, 3, 4. So 2 is also wrong. Okay. So how about number 3? For number 3, you start from 1, you end at 6, you end before 6, right? And the step size is 1. So 1, 2, 3, 4, 5. This number 3 is correct. How about the number 4, right? Range 6, you remember you start from 0. You include 1, 2, 3, 4, 5, but you have extra 0 in the beginning. So the only correct answer would be 3 here. Any questions about this? So why do I need this kind of range? Let me give you a quick demo in here. Okay. Let me see. This is selective square. Let me move this up a little bit. Okay. So instead of working on this, let me comment this out. So say, why do I need a range? Range would allow you to change a list using a for structure. So you can this for I in range of 6, right? For example, okay, and I have a list that has 6 things. Right? So if this list has 6 things, you say, let me generate the sequence from 0 to 5. And that's exactly the indexes for these elements. And then you can do this. You can say nums I plus equals to 1. And then print out nums. And you will see that this list actually Python exercise.py, you can see everything is added by 1 because I'm using this index approach. Index approach, you are actually modifying the list. If you use the regular for this thing in the list, that is a copy of the data in the list. So you be careful, okay? So this is the benefit of using the range with for each loop. Okay. Are there any questions about this part? All right. So let's look at this one. Okay. Um, let's see. The exercise goes like this. You are asked to write this function. And what this function does is to square everything in this list that are positive. For example, if you say 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, you're going to square all the positive numbers compared with before. So 1, 2, 3, 4, 5, they're all squared, but leave the negative and zeros alone. That's what you need to do. Okay. So here's the slides for this one. Can you do it? Can you write this function that would actually selectively square elements in this list? Okay. I will give you 3 minutes. Let's try it. All right. So get started. If you are done, you can vote in. One of us is done. Half time. Okay, so right. Last 30 seconds. Okay. And when you say if I'm done, you want to test your code to make sure it works. All right, due to time, I think we need to work on this together now. So the way you do it is you want to know first how long the list is. Say n equals to the length of this list, right? And then you say for I in range of n. This is a very nice way for you to say for all the potential indexes. If the length of the list is n, range n would give you all possible indexes. And then you just check if num list I is bigger than 0, I'm ready to square it. Num list I squared. Okay. And that's it. I'll return this num list. That's it. Sorry, I shouldn't return num list in here. What should I return? Return the number of elements that you have squared. So what I would do is I probably need a counter, right? To say how many things I have in the count equals to 0. Not in the count equals to 0. And then I do a count plus equals to 1. I'll just return count at the end. So let's try it. Okay. So if I say nums equals to 1, 2, 3, 4, 5, -1, -2, 0, I'll print selective square nums, and also I'll print out nums. Let's run it. So as you can see, I squared 5 numbers. The positive numbers are squared, and the negative zeros are left alone. Okay. So this is kind of the code here. Any questions? All right. Now, so for loops, it is useful that we kind of work on the structure in here using a range, right? A lot of time that's what we need. Now, for while loops, it's different. You have a while condition and then the statements you want to repeat. So this condition in general is some sort of Boolean condition, and then whatever you are repeating may change this condition. Hopefully, initially it's true, and then at some point it will be false. Okay, that's so in here, what I have is, for example, you say I want to get something from the user. If the user give me a 5, while the user doesn't give me a 5, I will keep asking. I have no idea how many times the user would take before they gave me a 5. So this is a good condition for while loop, you know? So for while loop, if this condition is true, then I would stay in here. But if it's false, I would get out, right? That is the idea. Are there any questions about this? Okay, now let's vote on this one. So I want to print out 13579. Which one of them would allow me to print out 13579? This one is a little bit long, so take your time. Let's vote in. Okay. vote in. Okay, about half of us voted in. All right. It looks like we are our votes are all over the place. Look at this. It's all over the place. 2, 2, 2, 2. So it's we disagree with each other, right? So maybe E is the right answer. We'll see. But let's start with A. I equals 1. While I is less than 9, I'll print out this. If I look at this condition, the way that I would say is I can never be 9, right? So if I is 9, I will never print out 9. In other words, this one is wrong to start with. If you look at A, right? I start with 1, you print out 1, and then I becomes 3, and then I becomes 5, and then I becomes 7, and then you increase I by 2, I becomes 9, but this condition would be false. Remember, for while loop, you check the condition before you run the code. So the first one, A would print out 1, 3, 5, 7. It doesn't print out 9. Any questions with this? A? All right. Now, how about B? We say I equals 1, while I doesn't equal to 9. So initially I is 1. This is true, right? I doesn't equal to 9. That's true. So we print out 1, and then I becomes 3. You check the condition again. 3 doesn't equal to 9, so print out 3. I becomes 5. 5 doesn't equal to 9, print out 5. I becomes 7. 7 doesn't equal to 9. You print out 7, I becomes 9. 9 doesn't equal to 9, that's false. So again, B print out 1, 3, 5, 7. B doesn't work either. How about C? C, I start from 0. I is less than 5. So that's true. So it's 2 times 0 plus 1. I print out the 1. Then I becomes 1. 1 is less than 5. So it's 2 times 1 plus 1. I print out 3. I becomes 2. When I is 2, I print out 5. I becomes 3. And then print out 7. And then I becomes 4. 4 is still less than 5. I print out 9. And then I becomes 5. That's when I'm out. So C is correct. 1, 3, 5, 7, 9. How about D? I equals to 1. In the beginning, I doesn't equal to 10. That's true. So I print out 1. I becomes 3. 3 doesn't equal to 10. That's true. I print out 3. I becomes 5. 5 doesn't equal to 10. Print out 5. I becomes 7. 7 doesn't equal to 10. Print out 7. Becomes 9. 9 doesn't equal to 10. Print out 9. I becomes 11. In fact, 11 doesn't equal to 9 either. So print out 11. And this loop is, in fact, an infinite loop. It doesn't stop. So the only correct answer would be C. That's the only correct answer in here. Okay, it's not A, nor B, or D. So only C is correct. While loop is, in general, harder to use and a little bit tricky. Okay. Questions? All right. So I think this is the last 2 slides about while loop. So what will be printed out in here? Num equals to 3, while num is bigger than 0, num minus equals 1. what is gonna be the value of num at the very end in here? When I print out num, what will be printed out? Please vote in. All right. So let's see. A lot of us voted for B. Why is it B? There is only one number. You're gonna print out only one number. You're not gonna print out multiple numbers because this print statement is not part of the while loop. So you're not gonna print out two numbers. For those of us who voted for B, that's incorrect. Okay. So you're not gonna, because this print is not part of the while. Only this num minus one is part of the while. That's one thing. Okay. So unfortunately, B is incorrect. Let's check. So num used to be 3. While num is bigger than 0, in the first round, num becomes 2. 2 is still bigger than 0. And then num becomes 1. 1 is still bigger than 0. And then num becomes 0. When num becomes 0, you are out of this while loop. That's when you print out num, you're going to see D. You're going to see D, not C, but D. Okay, for those of us who say it's going to print out 2 and 1, you are assuming this print is inside the while. It's not. Okay, it's not. Questions? All right. How about this one? I have this total equal to 0, and I'm adding it up, and assume that when the program asks for input from the user enters this thing, 1, 2, 3, -1. Press enter. What will be printed out in here? What will be printed out? So there are some typecasting in here, right? Only one of us got this one. Interesting. Vote in. Okay, so what would you say this code would print out? Or we're expecting to see some sort of error? I think we have seen a winner now. Winner looks like it's one of the choice. Oh, but it looks like we'll stop the vote now. Okay. The choices looks like A is the most popular, and then B. Okay, let's look at it. So if I enter 1, 2, 3, 1, we say total equal to 0. While num doesn't equal to -1, I'm gonna read it in and then add it to total, right? And I did typecast, so it looks like I'm using -1 as a marker, So the problem with this code is you're gonna see an error. In fact, you're gonna see an error. The error is C. It comes from here. But hey, let me compare num with -1. But when did you ever created this variable with negative called num? I never created it and start to use it. That's wrong. So that's why C is the right answer in here. This num was never created before you start to use it. You created total, so we can use total in here. That's fine. Num is created in this line, but you are using it before it is created in the while loop condition check. That's why C is the right answer in here. So how do I fix it? You need to create this num before the while loop, and then you can use it. The question is, what should I initialize num with? 0, 1, -1, or more than one of the choices? 14. So what should this thing be? As well, does it matter? Right. I want to add up a bunch of data together. All right. We'll stop the vote. Okay. A lot of us said A. When num is 1, I'm able to get into the loop, right? Because the condition is false. And then I read in 1, add it to total, and go on. So, sorry, 0 in here would work. So is 1, in fact. In fact, anything that is not a -1. That would work. So the job is for me to get started in here. So I get into the while loop, and whatever I had in num will be overwritten by this input data and added to total. Okay. Does this make sense? So D is the right answer. A and B are both good. A and B are both good. Okay. A is good, B is good. Now, if I have this code, I just say num equal to 0. What will be printed out in the end, like this print statement? What will be printed out in here? Okay, so let's vote in on this one. What will be printed out? Do I expect? So I'm entering 1, 2, 3 with a -1 in the end. right? So we'll stop the vote. A lot of us said, oh, it's gonna print out 6. One of us said it's gonna print out 5. In fact, I think it's gonna print out 5. Why is it gonna print out 5? The issue is this, right? So let me copy it, and let's run it. Where is the slides? Sorry. I think the slides are here. So let me see. Where is the code that we have? Okay, there we go. So let's go back to add stem, right? Back to lessons, week 2 Tuesday. So let's look at this one, right? I'll comment out this region. Now, if a total equal to 0, and then I'm ready to print out the sum, right? I think I need to indent them. And now let's run it. Python, enter number is 1, 2, 3, -1. See. 4 minus 1. Oh, I think I entered things incorrectly. Let me clear it. Okay. So it's 1, 2, 3, -1. And the total is 5. Total is not 6. Why it is not 6, right? Because the code looks good. The issue is this. When you first enter 1, num would be 1. And when you first enter 1, num would have a value of 1 in here. And for some reason, it doesn't allow me to annotate anymore. Feels like the annotation stopped working. I think let me close this. For some reason, sorry, the annotation stopped working. I'll close it. Okay. I'll restart the slides, lecture slides, Tuesday. Sorry. It's not here. Okay. We're here. Okay. So why does this fail? It's because in the first round, when you enter 1, right? Num would be 1, total would be 6. Total would be 1. And then you enter 2, num would be 2, total would be 3. And then you enter 3, num total 3 plus 3 is 6. And then you enter -1. At this time, num is -1. And total, in fact, 6 plus -1 is 5. And then you come back, check the condition is bad. So that's when you're out. That's why in the end, total is 5. You added this -1 to it. You added this number kind of incorrectly. This termination flag was used as a legitimate data. So how do I change it? There are several ways you can change it. Number one is when you see this num being -1, you break away. Instead of adding it, you can do something like this, right? You can say if num doesn't equal to -1, you add it to total. This would avoid adding it, right? But as you can see, there is a problem. I'm checking this thing again. In fact, only the last possible value is -1. So I'm doing all these things for nothing. So maybe a more efficient way is to say, okay, I'm adding this -1, so what? After the for loop, I'll just minus this number out. I know I added this num one extra time. I just take it out. That should be good, you know? So if I now run the code, 1, 2, 3, -1, now the total is 6. Okay. I would say this approach probably is slightly faster because you don't have to use that if statement that runs redundantly. Okay. Any questions about this part? All right. So we're done with while loops. So we talk about for loops with range. We talk about while loops. Now the last thing we'll talk about before we take a break is import. In Python, you can borrow packages from other programs. We call the Python library. It's just like you can borrow books from the library. So you can borrow them and use them. Import statement would basically allow you to borrow stuff from it. For example, you can borrow things from different packages. You say import random. It's going to say, I want to borrow everything that belongs to a random package. You say, I want to import math. Then you can have all the math functions that would allow you to use. Okay. So you can also import from your own file. Let me give you one example. For example, I have a function. In this example, I create a new file. I call this my tools.py. In this function, in this file, I have a function df1. This one just return 1. And then I have another function foo2, return 2. For example, okay, just silly functions. They don't do much, but I have this tools py file. So in this exercise, what I can do is I can do the following. I say, okay, I really want to use foo1 and foo2 in here, but they belong to a different file. So all I need to do is I say import tools, and then I can do foo1. I can call foo1. If you look at the code, say Python exercise.py, import tools.py. Sorry. No, sorry. Import tools, you got to say tools.1. Okay. So if you import tools, you say that package name dot function. Now, if you run it, it's gonna just, since foo1 really doesn't do much, but I can use this function. You can also import it like this. You say from tools import asterisk. This means just import everything, and now I don't have to use foo1. Sorry, I don't have to use tools.foo1. I can just call foo1 without the modifier from the package. Either way is fine. You say, well, why don't I do it in this way? So it's easier for me. The problem with this approach is, what if another package also has a function called foo1? Then there is a name conflict. So a lot of times people would prefer to say import tools, and then you use the modifier. So foo1 from the tools package. You may have another file that has also foo1. You say the other file dot foo to call the other version of the function. So import allows you to do this. Okay. Let's I think it's time for us to take a break. Let's take a break until 1:02. We'll come back do a quick exercise about import, and then do continue and break statements. Okay. So break time, everyone, break time, come back 102. All right, folks, get ready to come back in 1 minute. We will finish the third section for today. I think we're behind. Not by a lot, but we're behind a bit. Get started in 1 minute. Yeah. All right, so let's look at importing, right? So random is a package, and random has many functions. One of them is called rand int. Okay. So if I have words and then say rand int 0 length of the words, now what will be printed out by this one? I want to first explain what rand int does. If you go to the accounting here, if you say import random, and then you say help random dot rand int, what this one will do is it's gonna give you a helper message. Rand int method, it returns a random integer in this range. And this is one of the rare situations where the right side is potentially included. So range from 0 to b, including both endpoints. So it's going to give you a random value between these two numbers. Okay. So given this explanation, if you look at the code, going from 0 to length of the words have 3 words. So this is 3. This, in fact, would sometimes give you an error, because it's going to give you an index between 0 and 3. But for the words, the index is always between 0 and 2 inclusive. So we may be out of bound in here. Just be careful. Okay. So this rand int would basically, what we're trying to do is we want to randomly pick one of these words. One of the ways you can do it is, for example, import random. I say words equals to love, live, and laugh, for example. And then you just, for example, print words square bracket. You want to generate the index random.randint. You should say going from 0 to the length of words -1. You basically want to randomly generate a value between 0 and words -1, and then that would give you the correct answer in here. Okay. All right. So if you run this code, say Python exercise.py, sometimes it's love, sometimes it's live, sometimes it's laugh, right? You never know. So it's randomly picked. The other way that you say, I want to randomly pick one thing from it, you can also do this way. You say random dot choice. If you give me a sequence, it's going to randomly pick one for you. This is in general a little bit easier to use. Random dot choice, you can pick something from this sequence of words. Okay. Any questions? All right. So this is modules, import modules. Okay. Now, the next set of topics is break and continue. Okay. I totally understand we are talking about a lot of stuff in the 3-hour period, but that's what we signed up for, right? A summer class. So let's look at this one. Okay. When you think about break and continue, those are two statements in Python, and they also exist in many other languages. And what they do is they would allow you to get out of the loop or change the flow of the loop. So both statements are used to alter the flow of your program, and they're usually used in loops. Break would get you out of the loop before it normally finishes. Continue would say skip the current iteration of the loop. Okay. So what do you mean? So get out of the loop. For example, break is to say, okay, I want to run this loop 20 times. But at the 5th time, I say, well, it looks like we don't have to do it anymore. Then you can break away from that loop. So you can skip the remaining 15 rounds of iteration. Continue is to say, if something happened, you don't have to do those things for this current iteration. You just move on to the next iteration. Okay. So what are the examples in here? For example, for break, if I have a question like right now, we have 11 people in this room, okay, 11 people in the class right now. And I want to know, so find if we have a senior in the class, a senior student in the class. Maybe the senior student is taking this class to satisfy the graduation requirement. Okay, do I have that student? Do I have a student who is a senior out of the 11 people we have? Well, the question is, I can ask each of you, are you a senior? Are you a senior? Are you a senior? And the moment someone answered, yes, I'm a senior, if I still have a few students to go through, I don't have to go through the remainder of the students anymore. I already found it. That's when you can break away. Okay, so that's the idea of not going through all the 11 people, but maybe the third people tell me I'm a senior, then I can get out of the loop. Continue goes like this. For continue, the application is like this. I want to calculate the average of all the students, the average GPA of all the students who are cognitive science majors in this room. We have 11 people in here. I want to ask, well, what's the average of all the cognitive science majors in CSE 8A right now? What's the average of their GPA? So the idea is average GPA of cog science majors. How do I do it? Well, I go through each of the students. The first question I need to ask them is, are you a cog sci major? If the student said, no, I'm not a cog sci major, then I don't have to bother asking them their GPA because that's not my concern. If that's the case, I say, are you a cog sci major? If the student said no, I would say, continue. Skip the rest of the question about their GPA. Move on to the next student. That is the concept of continue. It allows you to skip part of the current iteration of the loop. It doesn't allow you to skip the remainder of everything in the loop, but the rest of the current iteration may be skipped. Okay. Normally, break and continue statements, they are hiding inside the if. So if this happens, you break. Or if this happens, you continue. Okay. They do not appear alone in the for loop. Normally, that doesn't make much sense, although syntax-wise, you are allowed to do it. Okay. So let's look at this one, right? So normally, if you have a while loop, that's what you do. Unless the user give me a -1, you're stuck in the while loop. Or this loop would run 5 times. Or finish the entire 5 rounds. Right? That's normally how it goes. But for break statement, you can use break to immediately exit the current loop. Okay, So that means if this specific condition occurs, break out of the loop immediately. Don't continue with the remainder of the loop anymore. So why don't you want to continue? Speed. If you don't have to do it, why do you do it? Right? So normally this is what happens. You have a loop structure, either while or for. You have some code before the break, and then all of a sudden you check, is this condition good? If this condition is good, you break and you get out of the loop immediately. You are out of the loop. You don't continue with the loop anymore. You don't skip just the current iteration. You are out of the loop. So break is a pretty brute force statement in here. Okay. So are there any questions about break in here? Let's look at this example. Message is hello, and then I'm going through the for loop, right? I'm generating all the possible indexes. And if message is L, I break. And this print is part of the for. What will be printed out by this program? Okay. Let's vote in. What is the output? Vote in. Okay. All right. We'll stop the vote. B is the most popular choice, and then E is next. So let's check. So message equals hello. The length of message is 5. Right, so I goes from 0 to 4. Whenever I see L, I will break. If I don't see L, I will print. And this end equals to empty string. Normally, when you print out something, it's going to give you a new line by default. But if you say end equals to an empty space, it basically means don't add the enter once I print out. So everything will be printed out in the same row. So the first letter I see is H. H is the same as L, that's false. So I print out H. And then I see a E. E is not the same as L, I print out E. And then I see a L. L is the same as L, I break. Once I break, I don't print out this letter anymore. I'm out immediately. So the correct answer is A, H-E. Break, you get out of the loop immediately. I don't care what's after the current iteration. I don't care what are the remainder rounds of the iterations. You are out of that for loop immediately. Okay. Any questions? That's what you have. For continue is a different story. When I say, okay, I want to skip part of the current iteration. Break is very brute force. You get out of the entire loop. I just want to skip the current iteration, but to try the next iteration as usual. Then what you can do is you can use continue statement. Okay. So the way that you use continue is very similar like a break. So if you have a loop, either a while loop or for loop, you have some codes before the continue. Then you have this if statement. If the condition is true, you execute continue. You may have some codes after continue. if the continuous statement is executed, this part will be skipped for the current iteration. But this part is not going to be skipped for the next iteration by default. In other words, if this continue executes, you skip this part. If the continue doesn't execute, you do the code before continue and after continue. Okay, so in the average GPA of CogSci majors, you can think the first part is to ask student what is your major. If the major is not CogSci, I don't ask the GPA question in here. So the second part is the GPA. So for some students, you ask GPA, for some students, you don't. And the continue would allow you to achieve this effect. Okay. Any questions? All right. So this exercise, message equals hello, and this is what I do. So instead of break, I have a continue. What do you think will be printed out in here? Yeah, please vote in. Okay. Think carefully. Okay, you have to understand what continuous effect is. I think we are doing better on this one than break. Okay. So we'll stop the vote now. A majority of us voted for the right answer. I think it's D, right? So basically, you are going through every letter of hello, and the interpretation of this statement is, if you see L, you skip this print. That's basically what it is, because if you see L, you're going to do the continue. The effect of this continue statement is to allow you to skip the rest of the iteration. You're going to print out H, print out E, and all of a sudden you see L. When you see L, you skip the print, and then you see O. So the correct answer is D. Okay. So the impact of continue and break are totally different. Do not confuse those two. Right. Are there any questions about break and continue? Okay. So we are done with break and continue. What did we cover today? As you can see, the 3-hour period is really long, and we covered a ton. Number one, we talk about basic how to get started, and then for loops with range, while loops, and then we talk about break and continue, import modules. Now, the last topic is nested loops. Okay. So nested loops is an important structure. I think what you will see in here is nested loops allows you to repeat, right? Loops in general allow you to repeat. Why do I need a loop inside the loop? So you have a loop in the loop. We call this nested loop. The reason is, in general, something like this. You may have a grid. You may have a grid. You have rows. You have columns. In fact, this is supposed to be a meme picture, but it didn't show for some reason. But the idea is, you say, I need to have two indexes, one for row number, one for column number. That's when you use a nested loop. Sometimes you can imagine loop. Each loop would give you an index. What if I need two indexes? Then you have a loop inside the loop that would give you another index. That's another way to think about it. Okay. So for example, you may be looking for something like you have a picture, you say, I want to modify every pixel in this picture. Pixels in the picture are grid. So you have row number and column number. You can use 2 loops to generate that. Or you say, this is the stock market variations over time. And I want to look for the period where the stock market increases the most or decreases the most. In that situation, you are looking for a range. A range would require you to have a starting point and ending point. That's when you use nested loops. Okay. In this class, we kind of follows this grid idea when we use nested loops. Okay, you're trying to create a grid. Hopefully that very soon we're gonna start to process pictures, and that's a grid structure. Okay, let's look at an example of nested for loop. So we have for I in range 4, for j in range 2. We call this the outer loop, and we say this is the inner loop. Okay, so the outer loop calculates like basically you can think the body of the outer loop includes a loop. So every time the outer loop runs, the inner loop would run a full round. You can think the outer loop is like the hour arm of a clock. The inner loop is like the second arm of the clock. The inner loop finishes one round, the outer loop moves a little bit. The inner loop moves another full round, the outer loop move on a little bit more. So that's the idea. The outer loop moves a little bit slower, the inner loop moves faster. Okay. Given this explanation, what would you say the output for this code will be? Okay. So let's vote in. All right. So vote in. Okay. What do you think this code would print out? This print statement will just print out a single asterisk. Okay. All right. Now, the answer to this problem, I think A and B dominates in here. Do I have a new line? I don't think any of the places printed out a new line. So it's going to be in the same row, either A or D, right? So altogether, you see the outer loop when I equals to 0, the inner loop J would go from 0 and 1. Every time the loop runs, you're going to print out the asterisk. And then I becomes 1. J would repeat 0 and 1 again, another 2 asterisk. I becomes 2, J would become 0 and 1. And then I becomes 3. J would be 0 and 1 again. It's like the inner loop do a full round, the outer loop moves a little bit. So I should see 8 asterisks. So A is the correct answer. Okay. It's not printing out any new line. So how do I get to B if you have another print in here? So once you output some asterisks, you print out. Sorry, this would not give you B. this would give you something like this, asterisk, 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 asterisk. So you print out 2 asterisks, then you have a new line. If you add the print, but this print is not part of the inner for. This print is part of the outer for loop. Okay. Any questions about this? All right. So for nested loops, the structure is like this. And other examples, like you say I, J, and then what you will realize is I stays put quite a bit, and J changes a lot. So when I is 1, J would go to 2, 4, 6, 8. And then I becomes 3, J would be 2, 4, 6, 8 again. So this would allow you to think about I is the index, J is the index. Inside the inner loop, you have access to 2 indexes. Okay. So to give you the visualization in here, you can think I equals 1, and J would be 2, 4, 6, 8. And you're going to print out 1 times 2 equals to 2, 1 times 4 equals 4, 1 times 6 equals to 6, 1 times 8 equals 8. And then once the inner loop is done, the outer loop update your counter, I become 3, and J would be 2, 4, 6, 8. Again, you're going to see 3 times 2 equals 6, 3 times 4 equals 12, 3 times 6 equals 18, 3 times 8 equals 24, and continue. So I would be 5, I would be 7, I would be 9, and J would always go from 2 to 8. So the counter for the outer loop goes slower, the counter for the inner loop goes faster. Okay. Questions about how you should interpret nested loops in here. All right. This will be a good challenge for you to see if you understand nested loops. It's not a nested for loops, it's a for loop inside the while loop. What will be printed out in the end? Okay, so think about this. This n double slash divided by 2 means n divided 2, but keep the integer division. For example, 7 divided by 2, this will give you a 3. It's going to throw away the decimal part. So this is called integer division. Okay, that's what it means. So think about what will be printed out. Right? So think about this. What will be printed out? Basically, what's the value of x? It's already like almost 2 minutes. Okay. I know your brain is probably fried, a little bit fried at this stage. With so many topics covered. Do our best to stay focused. And then we will have one more coding challenge. Then we'll stop there. Okay. But we can skip the last coding challenge. I think we covered everything we planned to cover. Yeah. All right, so we will stop the vote. Okay, we'll stop the vote. You look at A or E are dominating here. Either you say it's gonna print out 4 or it's gonna cause error. Let's take a look. Okay, let's take a look. So n equals to 4 initially. X is 0. And while n is bigger than 0, that's correct. So this loop would run 4 times. N times, right? N is 4, so this loop will run 4 times. Every time I will increase x by 1, so x would change into 4 after this loop. Remember, this division is not part of the inner 4. It's after the inner 4. So after this one, n becomes 2. 4 divided by 2 is 2. Then you come back for the while loop, n is still bigger than 0. So this loop would run again. And right now, n is 2. Right now, n is 2. So this loop would run twice. I will add 1 to x twice. So now x is 6. Okay, x is 6. And now I half n again. N is now 1. Go back, check the while loop condition. 1 is still bigger than 0. So I'm still good. Now I'm running this inner loop again. This loop would run once because n is 1. So now x is 7. And now half n equals 1. 1 divided by 2, integer division, you get a 0. 1 divided by 2, in fact, equals to 0, integer division. Because this equals to 0.5, if you throw it the decimal part, you only are left with a 0. Okay. So in the end, x would be 7. It looks like we didn't get this one. Okay. Are there any questions about this part? All right. So let me summarize, okay, what we learned today. We learned both looping structures, break, continue, and nested loops, okay? So if you have questions, I will be happy to